Hello, good morning, and thank you so much. Welcome everyone to today's session, workshop 1 on the basic knowledge of IoT ecosystems. We have today participants from over 20 countries. So it's a very international audience, and I want to tell you that we are videotaping this event. So if you don't feel comfortable being on video, you can stop that your video. We will later show that video to you and present it on YouTube. So what we're going to talk today is, and I encourage social sharing if you like what you see today. If you think it's of any value to you or your organization, please feel free to share. I also want to invite you to our upcoming energy and IoT session. I will follow up with all of this information after this event. You will get a short email with a video link and with everything you need to review this session in case you need to leave earlier or for some other reasons. So what are we going to talk today? Basically, this is an introductory workshop. Gary and me, who's my co-presenter and partner, will give you a broad overview into the technologies, the solutions, implementations, strategies, landscape, implementation plan, the value of IoT programs, financial benchmarks, everything that's necessary when you consider a project for your company or for your institution. Not to give you a too in-depth view, because that's gonna come from the follow-up webinars, but to give you a sense of what you have to look at and not missing out on certain parts of a program, so you can efficiently execute in your organization, or when you consider a project in your organization, sufficiently discuss that with all key players inside your organization. And the other reason why we're doing this workshop is basically to inform you on the decision-making processes, on the stakeholder processes, on your risks and benefits with IoT. Generally speaking, IoT is coming, your competitors are doing it, but if you're not properly prepared, if you're not align your goals and your technologies and your financial benchmarks, you're not going to get the effects that make you more competitive. And so that's basically what we're going to try to do here, just to open your eyes to the different aspects of an IoT implementation and what you have to look at. So I have started Accentec Technologies over a year ago, and we currently among consulting and educating people on IoT, we have several panel discussions. We are also integrating IoT hardware and software in different projects. Right now, we had different projects in education, in manufacturing, and in industrial automation. But what's always important is you always have to look at the specifics of your industries. There's not all one fit all. There are specifics to every industry, but IoT will be all encompassing. If you want it or not, it will affect how you handle your fridge on the consumer side, or how logistic chains will be optimized, how dispersed assets will be monitored. So the structure, while the structure is similar in all cases, the business outcomes and the implementations, the value drivers of those programs, and the security and compliance is different in many cases because you work in different industries. So that could be different from manufacturing to oil and gas exploration, to medical supplies, yeah. But each of them will use IoT in a way where it censors certain information, it transfers that information over gateways in the cloud, and we will show that later, and analyze information. But the business outcomes and the strategic decision making on those specific data you get visualized will of course be different according to what financial and strategic benchmarks you want to achieve in your specific organization. So basically what we are doing is helping our customers stay safe, helping them with streamlining their organization, increase productivity, and we have several things doing that. But I wanted today not so much speak about my company, but much more give a neutral and beneficial overview for you, so you can make your own decision even when you choose other organizations to go forward with your projects, and maybe if you have a very large company, larger organizations. But so you have the points in mind that you have to ask, you have the points in mind that you have to incorporate when you planning an IoT implementation. And that's the main aim. And more about us, I will put a short link in a follow-up email where I also will share the video with you for your review. And if you then contact me, we can also talk about the presentation. So in all together, the aim is to inform, to value your viewership today so you can achieve your goals. And now I give it shortly over to Gary to introduce me, and then going back to me introducing him.
All right, can you hear me?
Yes.
All right, fantastic. Thank you, Volkmar. So just a little bit about Volkmar. Volkmar Kunerth has developed numerous market opportunities in IoT, renewable energy, and industrial automation. He has a strong knowledge and experience in clean tech, sustainability, electronics manufacturing, robots, and IoT. Volkmar is currently working on his PhD in economics of the Internet of Things. Volkmar has successfully grown and managed several companies and business divisions, and has built teams and territories in Germany, Austria, Switzerland, the United States, and France. He is experienced in business to business, business to customer, and nonprofit organizations. Volkmar is fluent in German, conversational in French.
And now let me introduce Gary, my partner. Thank you, Gary. So Gary's a technology executive from the IoT sector. He's very industry recognized in the industrial manufacturing IoT scale business, and is a serial entrepreneur with 30 years experience in IoT, obviously when it wasn't called IoT yet. And he has leveraged companies. In 2008, he was very engaged in the low power LED business, and has also launched several IoT based product lines. So he's my technical partner, and as you saw, I am doing economics. I have a broad understanding of the economic and business implications, while Gary is an industrial engineer who has a very deep insight into the technical aspects of digital transformation, artificial intelligence, robotic process information. And he has an engineering degree from the University of Texas in Arlington. And our contact data will be provided at the end of the presentation, but I will follow up with every one of the attendants anyway in a short, brief email through LinkedIn after this. So what is IoT projects? They're not cheap. As I said in the beginning, they're expensive. And that's why it's so important to make sure they are right, proficiently executed, and will lead to the right results. But because in the end, it's about the competitiveness of your organization and your business. And if you don't get the right objectives, business objectives out of an IoT implementation, it costs you a lot of money. It exposes you to, and you will not have the competitiveness you desire for your organization to go ahead. And we, as an entry webinar, we help with that. And of course, as Accentec, this entry is webinar, as I said, is completely free. But ongoing, we also provide consulting services to make sure you get this, you get the objectives for your business. And we have also hardware, software, not all encompassing, of course. And that I need to say is like every project will have different players. There's right now not even the big companies who are doing IoT projects, be it a Siemens or a Microsoft, has a full stack solution. They all have to work together to implement a solution. So that's why it needs project managers and intelligence from people like us and others to point you in the right direction. And this is the first step here with this webinar. So now I give it to Gary, who's gonna talk a little bit about our partners here in Texas. And please, Gary.
All right, fantastic. I just sent a message out here in chat. I don't know if you've kind of seen, I've been kind of going back and forth. I got several monitors here, and I'm trying to facilitate the meeting here and letting people in and so forth. But please just go and chat if you can, and put your name, and if you feel comfortable, your LinkedIn profile address. Yeah, this is a webinar, but we want to encourage everyone to reach out, network, and build your own ecosystems. So I want to also encourage you to, if you've got questions, I know we're going to get kind of flooded here pretty quickly, but We'll start taking some questions as we're going through this webinar. So feel free to provide any questions that you like, and I'll try to keep up with that. Additionally, I'd like to invite everybody to, if you haven't done so already, sign up for the IoT Texas Meetup. This is a group that started about 7 years ago with 4 guys that went to breakfast, and has expanded into an international group of over 2,200 members. Of course, if you do look at the website, you'll see the numbers not quite that big, but we've got kind of a silent list. It's another 500 that have been asked to keep anonymous to some extent. So, you know, we can accommodate both of those. I also want to let you know that I will be moderating a panel on Friday morning at 8 o'clock Central Time. So again, please sign up and RSVP at www.meetup.com/IoT Texas. So recently I was quoted on January 1st in the Dallas Innovations magazine, and I'll just kind of paraphrase effectively. They caught me saying this at one of our IoT breakfast meetings, and where I effectively said, it takes a village to deliver an IoT solution. So no one company can really do it all. And as you can see why as we start to introduce you to the Internet of Things. So that said, Volkmar, you want to go ahead and kick us off and
Sure.
start in with an intro of what is IoT, and we'll go from there.
Thanks, Gary. I would say and encourage to write your questions, and we have a Q&A session at the end of the presentation. So we keep the flow going of the presentation, and then we go into your questions one by one and open it up at that point. Yeah, thanks so much, Gary, for that. Yes, the Texas IoT Group has been our partner in promoting our events, and we have done several events together before. So very simple. I mean, some of you have very profound knowledge of IoT, so it's probably a little bit simplistic what I'm saying now, but some of you might not. So I'm explaining the Internet of Things a little bit. Basically, the things are the objects, and the objects are embedded with sensors, and this could be software and other technologies. And as I said, this could be your fridge, but this could also be a robot in an assembly line. So there's the industrial Internet of Things, which has anything to do with production, logistics, maintenance, predictive maintenance, and so on. But then there's the consumer Internet of Things, which has everything to do with wearables and other sensor devices that you use in your everyday life. You know, your cell phone is in all actuality a IoT device, yeah, because it senses your fingerprints, it senses your position. And in all actuality, companies like Uber are IoT companies. Yeah, I mean, they're not necessarily called that way, but they utilize IoT technology for their business cases. So anyway, this webinar will be about the industrial Internet of Things. So basically, this the industrial Internet of Things has evolved through the convergence of different technologies, and that's why it's possible now. Yeah, I mean, there are multiple technologies like analytics, machine learning, commodity centers, and embedded systems that have become so cheap now that you can basically deploy it everywhere. And they will make up the new automation systems, which are currently SCADA-based systems mostly, every sector of our life, yeah. Home and building, and then in products, as I said, with lighting fixtures and so on, and the home cameras and all kinds of ecosystems. And we will have to look later at what the implications are. Yeah, on the business sides, of course, you have increased efficiency. You have increased throughput in manufacturing. You have robotics-enabled machinery that functions better and is connected to the whole supply chain. You have connected software and sensors. You empower you're empowered as a manufacturer because you understand how you improve operating efficiencies. But of course, there are many risks also because the whole system is in a way open. There are securities and risks to it. But basically, in all totality, you're making data-driven decisions with data you didn't have before. You reduce errors and reduce risks. You have predictive maintenance, which means like you can run your machines continuously and make sure that the machines are serviced in a way that you don't have to stop them because you have predictive maintenance programs in place. And if you think about a car manufacturer, let's say a VW factory, if they stop their production line for 1 hour, that's millions, if not tens of millions of dollars. Yeah. So on average, of course, it's they have researched that the Aberdeen Research Group calculated the average downtime costs per hour for manufacturing is $260,000. Yeah, and obviously that's a huge variety. And when those machinery goes down because they haven't been maintained properly, this is a case for IoT, because if you have predictive maintenance, you would have known days before already that the machine is going to go down if you don't do X, Y, Z and maintain it properly. And as I said, in large operations like Ford or VW, where you have a throughput of hundreds of millions of dollars of value every day, you have one bottleneck in the production line, it can cost you tens of millions of dollars if your production is interrupted. So that's why you can, with very low costs, basically identify those things. And so the other benefits in manufacturing is like people have the right parts at the same time. They know the costs of projects, they can better budget, and they can, if there is a bottleneck, move production to another area. So the quotas are unaffected and ensure that machinery is operating at maximum efficiency and improve security and safety. So this is kind of the overview on what it's doing in the manufacturing process. Now I'm going to a list of items that are important. As I said, you know, many of you might know it, some of you might not know. So basically the sensors are the devices that sense information from the environment, and that could be heat, or that could be pressure, that could be pictures, anything basically that's replicable from our bodies. Yeah, we sense things too. So and then you have a gateway, and the gateway basically connects the IoT modules and smart devices to the cloud. And for a mesh network is a network that you connect basically over a larger area of a larger facility. For example, if you have a factory, or you have like, there's also IoT in agriculture, yeah, like a farm, and you set up a mesh network, so the sensors can integrate, can connect to the mesh network at any location of either the animal or whatever you want to sense, basically. And the cloud platform is that is a very connected network. So, for example, the sensors can be included in all different kind of settings, in medical care, industrial settings, manufacturing, I mentioned, logistics, transportation, agriculture, even in tourism. So it's very important just to understand that we will go into a time where everything's going to be censored. Yeah, I mean, be it your street lights, your cars, anything you use will have a sensor at some stage. Nowadays, even clothing companies and shoe companies and so on have sensors. Not, of course, in all of their things, but it's happening. But we, as I said, our focus today is solely on the industrial Internet of Things. So what we also have to see that the gateways, they collect massive amounts of data. So why do we need a gateway? Because you need to kind of pre-process the data before passing it on to the cloud platform, and have already create some meaningful intelligence on the gateway. And the other functionality of the gateway is basically that the gateway receives information from the cloud to send back to the devices, so you can autonomously manage the devices in the field. And so basically those gateways run on different internet network protocols, yeah, which will for short distance like Bluetooth, for longer distance LoRa or Zigbee. I'm gonna go into these things again later. And as I said, the mesh network is for bigger applications like factories, like smart metering, and allows for including the endpoints of the edge devices. So let's go to the next things here. So basically the sensor to gateway, then there needs to be a protocol so the sensors can speak with the gateways, basically. And there are different protocols are used. One of the most common is MQTT, which has been in place for decades. And there's also a protocol which is being used in current automation. And you need the gateways basically to have the following benefits: increased battery life of the sensors. You can connect it to satellite connectivity. So I have two projects possibly right now, which deals with satellite companies that do agricultural projects. For example, if you want to monitor a big herd of cattle, which is possibly in hundreds of square miles. You can put sensors on the cattle. The cattle then can connect through the gateways to a satellite, basically. So with the satellites, obviously they're very good. Connecting to satellites is very good for low data, low data streams with a lot of participants, and that could be a lot. Let's say you have a large cattle herd in Texas with hundreds of thousands of cattle over 100 square miles. That's an ideal case. It's not so good for large amounts of data, because it's too expensive, and the throughput, and as I said, you have the limited battery life of the field sensors and so on. And but as I said, depending on the case, you can use different wireless technologies. I mean, Zigbee, for example, is very much used in building technologies, and with small powered radio devices, and low power proximity devices. And then you have BLE, Bluetooth, low energy. It's also a low energy based communication protocol. And speaking of that, we can give you later a presentation with text and everything if you request that. So you don't have to write it down, and you can watch the video later, but it's up to you, of course. So we are having a large variety of protocols because each protocol fulfills a different need for the devices and for the specific case. So it wouldn't be very good to manage your building automations with a satellite, for example. That would be a wrong case. So Z-Wave is another mesh technology that is for smart home products and enables smartphones or tablets to be one-touch devices, and allows for remote control. And Z-Wave has already reached 2,400 interoperable products with 700 brands worldwide. So that's the other thing. There's one thing is what specific technology or what specific protocol is good for what user case, but then which protocol, because the protocols are associated with ecosystems, work with what tools and with what products. So we have a whole, let's say, network puzzle of different technologies, and as a user or as trying to implement those systems, you have to make sure you have the right thing, and you can connect the right products in the ecosystem you will produce later. So it is quite complex, even on a technical level. And of course, we can only provide you right now with a broad overview of all those different protocols and why they are there and how they are connecting, but you will see more in our follow-up in a few days. as regarding, for example, to LoRaWAN, the LoRa is a low power wide network modulation technique, and I've used it in a project with milk cows actually, where the milk cows got egg-shaped boluses that were put into them, and then to figure out what the chemistry of their stomach is, so they get the proper diet, but also finding out by temperature when the right time to inseminate is, because normally and previously those cows were artificially hormonized, so they can be inseminated. So now we can do it without hormones by checking on their temperature. And basically the bolus in the cow was then connected to a LoRa network with LoRa low power network, because the boluses in the cow, they obviously didn't come out and they had to stay in there for years. So you need a low power wide area network that's not taking too much battery. And the LoRa network ran on a mesh network we installed on the farm. So just to explain to you a practical example of how something like this works, basically the protocols then were run. There was a user interface, obviously, on a screen, touch screen, and computers, which were then enabling MQTT through HTTP. So you run the user interface and on HTTP. So then another form you have probably heard of is Cellular IoT, basically running these, what you could also do through cellular networks. And basically that would mean you use those in example of this cows now, connect your boluses or your sensors, which you have in the cows, you could directly connect to a 5G network. Now, in the case of farms, often this is not possible because there is no 5G on those farms, or sometimes there's no cell phone connectivity at all. So you have to have other things. You have to have other technologies connecting. And Wi-Fi mesh network are already explained. So let me show it to you now here. Again, what I explained in the last couple of slides, how this looks in a, let's say, a more graphic way. Yeah. You collect the data on different levels. Yeah, you go from left to right. Yeah, this is a level of the things. You have the sensors, and personal devices and robots and security devices like cameras, connect to middleware. Here you have the M2M connectivity, the user control level factory, the routers and switches, and through the creation of this intelligence, you in the end you reach your business objectives basically. But I mean, this explains the whole timeline. However, in the end, and I will show that later, you have to start from here. Yeah, you have to assess what you want to do, You want to have lower total cost of ownership, improved asset utilization, and fast time to market. So you can also go from what you want to reach at the business level, and then you have to determine what from the business level, why you have to have certain sensors, certain devices in place that you achieve your business goals. Yeah. Or if you have machines and robots in place, how do you connect them? So for example, robots, so you have lower cost of ownership by maintaining the robots properly. So it's all interconnected, and it's extremely important to be sure to deploy the right protocols and the right sensors for the right tasks and objectives you want to reach. For example, if you're trying to monitor a jet engine, you create 10 terabyte of data about the conditions and the performance of that in half an hour. Yeah. So obviously you don't gonna do that with a satellite connectivity, yeah, because that doesn't give you the throughput of information. So you need a very insightful and analytic data management and big data management tools to do that. And you need to be very sure about your specific case before you go and implement a solution and that fits you. So now we show it again in a more graphic way, and so we have the devices here on the first level. Then we have the flow of data from the devices to connectivity, Bluetooth, Wi-Fi, to through the edge, yeah, to the connectivity layer, and then from that we go in the internet. And you can have, that's another thing you have to decide in your organization. What kind of cloud infrastructure do you want to have? Yeah. So we have the connectivity from the VLAN, WLAN to the internet. And from the internet, you go into the cloud. Yeah. And there are different cloud providers, AWS, Microsoft, Azure, and so on. Those are the big providers. But you have to decide for yourself. Maybe you want to have a private cloud because your data is so sensitive, you don't want to have it in a public cloud. Or you have a hybrid cloud, so you manage certain things in your private cloud, basically your private data center, and part of it in a Azure or AWS data center. Or you go completely public, you know. So all these considerations you need to just have when you go to that level. Yeah. Obviously, those large data companies like Google, Microsoft, and Amazon, they have large insights into big data analysis. That's their business and everything. So they have maybe functionalities in their cloud you might not be able to do on your private cloud. But nevertheless, you have to take all things into consideration, your safety and security, your adaptability, and so on, before you make a clear decision on what you will deploy. If you go private or hybrid, or you go public cloud. And then you have the service and application layer. Basically, this layer here is the user layer, is like the data here that's analyzed will be getting on a user interface, and different players can have access to different data. Yeah, for example, the CEO of the company can have access to all data, and the worker only to a certain subset of data that is important for him to do his job. Yeah, and when we go back to the cows, you can have the guy who's monitoring, who's on site, or let's say the doctor who has to inseminate. He has a screen that gives him certain information, and then the owner of the herd has another set of information that is more relevant for him. And all this is visualized, yeah. So, but you have to see, you know, obviously that's another, you have open interfaces to your cloud, yeah. You have it from the devices, from the internet, basically through the internet, and then you have your computers and touch devices. So those are of security concern, more or less. Yeah, so you have to make sure those are properly monitored. You have safety protocols in place. You have safety protocols for your workers in place. So, for example, the devices are not getting lost, or the access to the devices is secured, and so on and so forth. So this is very important. And this here gives you, this is from McKinsey. It's a little bit old, but it gives you a very good explanation of the economics. By economics, I mean the economics of the sellers of the different channels and that go into the IoT infrastructure. So when you buy, so 30% is hardware, which is the edge, the devices, the components, then 10% connectivity, and that's approximating also the costs that will be relevant for you. Now, I have to tell you, some companies are really overcharging in connectivity, sometimes 10, 20 times to make up for the deployment of their devices. So you have to be very careful to look and make sure. For example, we had a project with an RV dealership, and I looked at several suppliers, and there were 3,000 RVs on the lot, and it was about geofencing. Geofencing means basically you put a sensor on the RV, and every time the RV departs the area, the sensor sets an alarm because it goes through the virtual fence, so to say. Now, the connectivity costs that I was offered were like $20 per device, which means if you have 3,000 RVs, that would be $60,000 a month. Yeah, I mean, no one wants to pay that, obviously. So I did my research, and I found under other options that would have reduced that costs at least by 90%. Yeah, so it's very important to make sure you're not getting cheated with costs that don't reflect the real costs of connectivity. So then you have the data networks and software and services at 60%. Software and services, data analytics, the platform, the cloud, all those things that make the majority of the costs and the biggest value drivers. because in all reality, connectivity and hardware is somehow commodity. So when you deploy that, you want to make sure that maybe you own your hardware. Yeah, because if your service provider connects you with the hardware, you have the infrastructure, you're basically hooked on the infrastructure, and then they can charge you on the software as a service. But as I said, you know, if you have questions, come back to us later, and I'm more than happy to help you to find out what is specifically relevant for you. I'm just saying you have to be very careful not to be overcharged, not to be hooked into something that might not be relevant for you, and or into software as a service contracts that don't basically deliver the value you need for your organization. So it's just to caution you to be very careful. And then overall, and I mentioned that before, you have the security layer and governance layer, which is extremely important, of course, because you are open. Now with the cows, for example, I said they're in the stomach, so that's basically, but there are also cow sensors that are in the ears, and someone could go and get that, and then you have to make sure no one gets into your network when you shouldn't. Or we had a project with cell phone towers where we were monitoring electricity, battery, and fuel in those because they run with diesel, not here, but in emerging countries, that people don't intrude the cell phone towers, or they don't steal the batteries, and then you have no more connectivity and so on. Yeah. So there's depending on your specific situation, there's a specific security and governance team or person who needs to make sure your things are secure going forward. That's a very important aspect, and that encompasses your whole system. And then, of course, the management layer. Again, on the management layer, you have different constituents that, according to the work they're doing, they have different levels of access to your system. So the worker who goes to the cell phone tower every 2 weeks, obviously has a different access to data than the CFO of the company or the CEO, who need to understand and see the whole system and the implications of all 500 cell phone towers. So this is very important to know. And the solution, as I said, process goes top down. You have your services, what you need, and then break it down from there, what you need in terms of analysis platform, data networks, and so on. And I alluded to that before. And now I give it to Gary, who is telling us a little bit about the IoT landscape.
Yeah, and thank you. So as you can look at this slide here, you can pretty much see that the whole landscape of IoT is very fragmented. You've got all these different areas here, different elements and pieces and parts that you have to put together to effectively build a full end-to-end solution. So let's take a quick look here at just what that whole value chain looks like, as I kind of refer to as the A to Z. First of all, you'll have to go through and you need to source your sensors or your edge devices, and that so you'll have to have some kind of a silicon vendor that you're working with. You'll either have to do some design work or build devices or buy off-the-shelf devices. So there's various different ways to do all that. And if you choose to do that, then you've got device OEMs you've got to work with. And then now that you've got all those devices, you're going to want to connect those back into the internet somehow. So you've got to work with some kind of a networking protocol schemes, companies that can provide that backhaul, cloud service providers, and so forth. So effectively, you're trying to collect that data from the edge. So once you get that data inside the cloud, you effectively want to put that into a large data lake. And once that data is inside a big data lake, you're going to have some type of software to manage all that data, or manage the, I should say, manage all that data and manage all the devices that you're connecting to the internet. Obviously, that's what we've been referring to all along as an IoT platform. So you'll need to get some type of an IoT vendor involved, and they'll help you through those particular issues there. So once you've got all your data, you've collected all this information from the edge, you're going to want to take a look at that data somehow, some form or fashion. So we've got various different ways to do that. We've got analytic tools, we've got business intelligence tools, all of which are going to dip down into that large data lake that you've been creating with all this information you're collecting. And you want to connect that data lake also to the enterprise. So you can start grabbing information from the enterprise and start pairing up all this data so that you can start providing some insight that you've potentially never seen before. So that involves getting involved with some type of analytics vendor. Tableau, Microsoft, I mean, there's a large list of different companies to provide those types of capabilities. And overall, I mean, you want to probably take a look at a systems integrator that can, because if you're connecting into that large data lake, you've got your ERP system that you want to tap into. You want to tap into your warehouse management system, your inventory systems, various different elements within the organization. I mean, even having HR data makes a big difference in being able to pair all that with all this information, again, you're collecting from the edge. So that's where you start making those pairings. How do you know that one of your employees that shows up in the database right now is 1, 2, 3, 4, 5, that has a sensor that indicates that, oh, they've fallen, but I need to get up type of deal, where you've got, monitoring the health and welfare of your personnel, say on the factory floor. So you want to be able to tie that back to your HR system and start pairing data. You want to use location data. Is that employee beyond that yellow line in an area that he's not supposed to be in, he or she? And particularly reaching into that HR database and notifying management or whoever needs to get that information beyond just the employee. So again, you're pairing data that you're collecting both in the enterprise and on the edge. Kind of an interesting use case. There's an organization that went out to the shops of Mandalay Bay in Las Vegas, and they set up a kiosk and they started sniffing for cell phones and Bluetooth connections and the whole bit. And they were able to effectively look at some facial recognition information, get an idea, do some trying to figure out who's there. We're talking about a bunch of small kids, adults, whatever. And they started tracking those people throughout the shops and collecting the data, the demographics, connecting that information with sales information from the various different stores. They were able to figure out insight that they would have otherwise been very difficult to have collected. And specifically, I'm referring to the fact that they recognized that the shops that were located near Starbucks were doing better than the shops that weren't. And they were able to pair that information and come up with the fact that when people smell coffee, it puts them in a good buying mood. So with that information, they armed all those other stores that were outside, away from the smell zone, with coffee beans in cups and so forth. So, you just never know what you're going to be able to do with all this data that you're collecting on the edge, and then pairing that again with enterprise data. So as you can see, as you start building your value from IoT, you're wanting to gain those general insights, create some value. You know, the value that I just went through on that example with the shops in Mandalay Bay is that I can increase sales if I have coffee beans in my store. So, you know, all that said, we want to look at the fact that you've got to have some level of security that's going to go over our umbrella, that whole organization. And we'll talk about security a little bit further in the webinar here. But so let's go back to IoT platforms. Lots of IoT platforms out there. What I want to do is we'll talk about the components of what makes up an IoT platform later. But as far as just doing some analysis in the market, because you know the platform will either make or break the project. Period. That's just fact, I guess. The market of IoT platform companies is not consolidating, despite the number of articles that are circulating now around the internet claiming that the IoT market is showing signs of consolidation. Our research is actually showing that it's just the opposite is happening. The market is beginning to even fragment even more. So kind of putting a stake in the ground, because as I said, the platforms are coming up and going away and getting bought and sold and consolidated, and you know, someone else pops up with an IoT platform. So kind of putting a stake in the ground and looking at the data as it was a couple of years ago, what we were able to do is determine that there was about 450 IoT platform companies that were making IoT that made our IoT analytics list back in 2017. So we then looked at that list, and 47 of those ceased to operate today. 70 of those were acquired, and of those 70 acquired, 22 continue to operate standalone. So, you know, one might think that reducing the total number of IoT platforms to 355. However, through our research of hundreds of websites and presentations and other materials, IoT Analytics identified an additional 265 IoT platforms, which satisfy the IoT Analytics definitions of an IoT platform, hereby bringing the total now to 620. So, as these additional companies include new IoT platform startups like IoT Tech, founded in 2017, as well as IoT platform providers by large companies or joint ventures, for example, Atom OS, open manufacturing platform by BMW and Microsoft, launched in 2019. You can see how the things just kind of ebb and flow. I mean, even Siemens has their own specific IoT platform that is just for Siemens products. So you try to integrate that with other things, like, as I said, going back into the enterprise, and it kind of doesn't quite make that leap. So there are organizations that have that, so those connectors already built in to their IoT platform, so that you can make that quick connection right into SAP. And start pulling out data immediately. So, you know, there are several reasons why many of the small players continue to survive in the market with hundreds of competitors. There are many niches in IoT, as I mentioned, Siemens. By focusing on specific use cases or industries, some firms bring a value proposition to customers that the larger or more horizontal players can't do. Again, Siemens would be a great example of that. So it's easy to become an IoT platform company on paper. Several companies seem to have gone the route of doing a customized IoT software project with a customer and afterwards standardizing the elements of that solution to market them as a platform. So it isn't easy to become an IoT company, as I said, on paper, but many of the small providers are profitable. Our team has talked with several providers who sometimes just cater to 5 to 10 customers with a team of, say, 20 people, and are profitable. Their customers seem to enjoy the service they're getting, so one can imagine that these players are going to continue to exist for a while. So let's talk about some examples of IoT strategies. As our advisory service focuses on the digital transformation and business process revolution powered by a trio of ubiquitous internet, pervasive low-cost connected devices, and the growth in data analytic solutions. So the Internet of Things refers to a system of interrelated, internet-connected objects that can collect and transfer data over a wireless network without human intervention. The personal or business possibilities are endless. So looking at what was the strategy in the past versus where is the strategy going forward? So in the past, we effectively just tried to put things up in the cloud. We need those connections, and we use various different software packages, say from Microsoft, IoT Hub. But I know of several companies that have taken that IoT Hub, including Microsoft, and have created a whole platform around that, where Microsoft refers to that as their platform is IoT Central. So that's the going forward. We're building in AI now into the platform. We're using solid partnerships now with cloud providers to be able to give us that extended capability of just an IoT platform that ingests data and allows you to do some business rules and give you some kind of graphs and charts. What gets exciting, as I've been saying all along, is you've got to mix and pair that data with the enterprise to get that additional insight. And I hate even mentioning this, but there's a trust me factor to some extent. I've found this to be true over and over and over again, and delivering various different IoT projects and smart apps. First application, we'll justify it. We'll get maybe on paper 9 to maybe 18-month ROI. Project number 2 might have had it in mind. Now that we've got this internet infrastructure, we've got a bunch of access points in the building we didn't have before. We start looking at additional projects we can build on top of that. And that becomes project number 2. As I said, it was kind of in the wings. We were thinking about if we had the infrastructure, when we can add this additional capability, but it's the tertiary project that we never thought about, that, oh, now we've got all this infrastructure in place, and oh my gosh, now that we've got all that and we can pair that with enterprise data, ROI just goes through the absolute roof. Never have that in mind from the very beginning. Don't even know where we're going on this journey. But once we get to that point, it's mind-blowing. I don't know how to explain it other than calling it the trust me factor. But that's hard to have that conversation with the CFO, right? So all that said, what we're seeing, again, as I said earlier, we're seeing this whole blending now of AI and IoT ecosystems. Some of you might have even seen AI IoT as an acronym. So it's becoming very difficult to separate the artificial intelligence from the IoT platform, because we're adding so much more analytics and preventative maintenance information and so forth, that we're able to glean directly off those edge devices that we've got all these sensors connected to.
You should have a full size
I'm sorry, do we have a question?
No, it's we have the questions later.
Okay, all right. So you want to go ahead and advance to the next slide?
Okay. So how are you getting the insights, IoT insights out? It's basically 3 steps. First of all, you need to prepare the data and do a precise data analytics on it. So and the quality of the data is obviously extremely important and relevant to what you can get out of it. Then you analyze and visualize it, which will affect the precision. Machine learning is quite useful to predict certain outcomes from certain data. Of course, you need to have the right algorithms and the right machine learning tools on top of it. And then you process and activate and visualize the data. As I said before, the visualized and actionable data is different for what constituent you're talking about. Like the CEO will have other data than the CFO or the chief production officer. It's always to relevance for the actionable insights. And the relevancy depends, of course, on the business strategy and what insights you get from the data you use then for your business strategy. And obviously it's contextual to what business you're in and what you're trying to achieve. This is just a very highlighted process here. We are not machine learning experts, but we work with some in the field, so we don't cover everything in that level. So now we come to the question: how do you implement that in your company, or your organization? You first have to understand what is your current device structure like. Do you want to connect to the existing automation structure with your existing devices and build a hybrid? Do you want to rip it out and have a complete new one? How do you utilize the cloud? And how do you combine the data you have already collected with the new data? And then how do you generate new insights to create business value and save costs or increase your revenue? Or, I mean, in the end of the day, you have to generate this, and all the before steps have to be worked and coordinated together, so you have your insights and create new business value. Because if you have no business value out of this, all the other efforts are useless. So that's why I said in the beginning, you have to start from, okay, what are your objectives? And then what is your current status of your device structure? And how do you get there to generate new insights from that? And basically, you need several human resources tools, which we will talk later about it. What people do you need in the projects? How your pilot projects will look like? How you will deploy it? Who will deploy it? Who will identify your IoT objectives? Where are the use cases? What are other current digital transformation projects going on? How do they fit into the new IoT infrastructure? How do they fit in your current company's needs? How do you create use cases for those needs? And how can you understand the IoT technology that will support your use cases and your business outcomes? So, and all of this has to be really well aligned with a roadmap and project objectives and so on. So you get your maximum insights and create the business value out of it. And for that, you will need different knowledge leaders who can help you with choosing those right things. So everything is interoperable. You get gateways, your communication protocols, your platforms, your cloud data, and so on. All of that needs to be planned in advance before you implement and prototype your IoT implementation. And so you need a team that meets all of these requirements and make sure you is also aligned with your current industrial embedded systems design. So you need electromechanical knowledge, you need back and front development, and you need the general technical expertise that interrelates with current ecosystems and current what you have and what you want to do. And we coming later to the skill set of the teams. Gary will talk about that in very much detail, but overall you need a information system expert, data scientists, statisticians who work with the data scientists to pull up the right statistics. You need IoT integration people, you need people who understand sensoric and cognitive machine learning, and so on. So we will go into all of these things in a different setting very soon, or you can ask us questions later on. So as I spoke about it, you need the technology and use cases, the people and the processes in place. You need project managers managing the processes, the people and the technology processes. You need technology. For the technology and use cases, you need specific people who are very knowledgeable in this point. So you reduce the errors, you get empowered, and you have the cybersecurity in place. You get your objectives out of it, like predictive maintenance. We mentioned that before, and other useful business outcomes. You either want to reduce costs or you want to increase revenue, and specifically to that case, your IoT needs to support you accordingly. And those are the 10 elements of success. Identify value, build your team, get the right feedback, have trained people, look how your system creates customer value, enhance customer value, be sure you use the right connectivity devices and protocols, have your security in place, be a compliant, measure your success, and have feedback loops. So you always make sure you have your identified values and customer value in eye, and so it's a quite complex system of things you have to do to properly do that. Now there are very simple solutions. I talked about that RV and geofencing. Basically, there you have those RV park. I mean, could be also military or construction equipment. You put the sensors on there. There's a software. You integrated and basically it's plug and play, connects to the cloud. Everything is a one-shop solutions, but still you have to make sure, does the company fulfill my security needs? Does the company, is the company compliant with all the protocols, and does it fit the costs, reflect the value that I want to achieve from it? Yeah, obviously, if I have to pay 60,000 per month for connectivity, as I mentioned before, it's not worth the deal. Yeah, so the outcomes and costs, the costs have to be reflected in what you want to achieve, and the costs obviously shouldn't be higher than the business value you get out of it. Yeah. So that's very important. And again, here, when it speaks about identifying value, is what is your business goals, and what are the short-term and long-term business goals, and how do you define the IoT use cases associated with those business goals, and how do you identify the supporting business initiatives with that. And then once you have defined your goals and you find they are attainable and measurable, and they drive the financial and business aspect of your business and what you want to achieve, then you go into the implementation and phase, and not after. Yeah. So if someone comes to you and says, "Hey, I just want to sell you that technology," whatever, you first have to figure out, is it something that applies to my goals, and is it something that's attainable for me, and when I measure it, can it support my business values? Yeah, even if the technology is a fit, if it's not a fit for what you want to achieve in your business, it's useless. Yeah. And that's why you have a bunch of constituents in your business who need to clarify those and make sure the IoT implementation drives your business and financial impact. So what you want is operational performance increase, yeah, which you get with which results in operational performance boost, and you want to decrease your costs, and you want to minimize your risk, you know. So your risk assessment and costs have to be seen in conjunction with the operational performance. And that always depends, of course, with your specific business case, you know. So, for example, we had that case from pipelines, oil and gas pipelines, who were compromised, you know. So is it worse? I mean, what can I do about it? First of all, to avoid that. That's an IoT case. And is it in the end worse, whatever, my reducing my maintenance costs, but then compromising my security, the security of my operation? And if I'm very mission critical, like a hospital or an oil and gas pipeline, I really have to make that strong assessment for my operations. Yeah, or if I'm a factory. As I said, the factory comes to a standstill, you might accumulate $50 million of costs per day. Yeah. So in the end, what's my tactical, what do I want to achieve on a tactical basis? Am I a consumer facing business? Will I then increase better customer experience? Will I optimize my offering? Will I generate new revenue streams? That obviously depends on your current situation, because if you're a supplier, third level supplier to an automotive company, you don't have real customers. And the automotive company doesn't care about your customer experience. It cares about the benchmarks that they give you in terms of delivery and quality. Yeah. So and obviously you can reflect that with your IoT. You know, you can reflect your inventory levels. You can reflect your quality assurance with IoT offerings and improve those. Yeah, but it has to be your operational and tactical drivers are very specific to you and your use case. And it's very important to know that. So now I'm giving up to Gary. Now we're going to the next step. Basically, how do we build a team? I reflected on that before, that satisfies the successful implementation of an IoT project.
Yeah, so building a team is extremely important when it comes to successful projects. So one of the things that we need to do is we need to find a champion. We've got to find somebody within the organization who's going to go to bat for the project, and also be able to handle not only just the addressing technical issues, addressing management issues, addressing internal politics, someone who's also going to be able to make sure that your particular project is going to the top of the stack. So you need to find somebody, again, who's going to be that project sponsor. So when it comes to building that team, you really want to make sure that you've got representation throughout the organization, and you'd be very surprised when you start bringing these different elements within the organization together and finding out things that you might not have thought about or you're about to overlook. You've absolutely got to get the R&D department involved. IT, check, right? Corporate marketing, have you thought about those guys? What's going to happen once you get this IoT project? Can you get any mileage out of that from social media, publicity, whatever that happens to be? Your sales department, they might be involved in creating a whole new revenue stream, monthly reoccurring. So you want to have those guys involved potentially. Finance, got to have the money. Support, who's going to keep this thing running? You don't necessarily go in with knowing exactly what that end of life is going to be, but you need to at least plan for it to some extent up front. So keep in mind that a program manager is going to optimize the efficiency of the team and manages that momentum, right? It's a strategic program, not a project. So you need to be able to focus on the benefits. The connectivity is just one part of the IoT program. A motivating team to care about your project, right? Again, having that right sponsor. Make sure you get that business buyer on board from the finance department. The business contact should manage the interface between the business and IT. So what we'll see here is when we start talking about security, kind of the importance of how close do we need to get this relationship, and can we stiff arm IT a little bit some point, because IT is going to want to have passwords that are bazillion characters long, special characters, this, that, and whatever. And in some cases, that's just not practical. So again, just make sure that you provide a complete information within the team. Keep it simple and don't raise new concerns. So let's take a look at the various different team members here, under these departments, if you want to call it that. So the corporate team, you need to make sure that there's somebody who's going to manage those relationships, those third parties. Then, if you're going to try to build some of this internally, you're going to have a digital architect director, some data scientist, an application developer, infrastructure, cloud, IoT security specialist, a web portal developer. And that team can be as small as what we're indicating here on the slide, or it could be massive. On the business side, need to make sure that you've got the right business units involved. You're focusing specifically in areas with domain knowledge. If you're setting up a factory, a smart factory, you better understand how you're going to interface to your pumps, your HVAC, the various different elements within a factory floor, drill presses, on and on and on. So you need to have someone who at least understands how that data is collected, what data is important, how to interface with that data, how to parse that data, and then what does that data actually mean when you do have information. So if we're collecting a lot of, say, vibration data from a pump, you want to have a little bit of expertise there to talk specifically about the areas where what is too much vibration, or where is a bearing going loose, wearing down, and provide some preventative maintenance information. So again, just looking at our list here, your corporate team consists of kind of your IT-ish guys, the guys that are going to be very, very close to the project. And then here on the next slide, we've got kind of how everyone's kind of interfacing here, your application programmers, your data scientists, your product expertise with say engine control maintenance and so forth. So that brings up, who's going to get all this information, the technology directors. What's the typical team members going to look like? Product engineers, specialized engineers, and then you've got to get your project management, your agile, your scrum masters, your mobile application developers, and then of course your guys that are understanding the gateway and the edge applications, so that we can extract all that data from the edge and bring it up into an IoT platform. So speaking of IoT platform, an IoT platform exists independently between the hardware and the application layer of the IoT technology stack. It is an ideal scenario. It will integrate with any connected device and blend in with device applications. It will also enable implementations of IoT features and functions into a device, all in the same manner. So we believe that there are 8 things that you should look at when evaluating an IoT platform. And specifically, there's the must-haves. Your IoT platform must have connectivity and normalization. So that's going to bring different protocols and different data formats into one, we'll call it software interface, ensuring accurate data streaming and interconnection with all devices. It needs an element of device management. You've got to be able to connect the things. Those things are properly working. They're seamlessly running patches and updates for software and applications running on the devices or the edge gateway. You need a database, scalable database, because you're going to collect megabytes, terabytes, and we're always talking about petabytes, right? If we're collecting engine data, we can get a petabyte of data in 30 minutes. So you've got to have an expandable, scalable storage capabilities. And typically you'll do that either in the cloud or some kind of a hybrid cloud because of cost. And that way you've got a little more control over what your data costs, your disk drives, and the whole bit. So then the next element is obviously you got to process all this data, and you've got to have some kind of actionable management system. So that's when you're kind of bringing your data to life with rules-based event action triggers, enabling execution of smart actions based on specific sensor data, also known as a rules-based engine. You need analytics. You need to be able to perform a range of complex analysis, from basic data clustering and deep machine learning to predictive analytics, extracting the most value as you can from your IoT data stream. You need some type of visualization. That kind of brings that human element to it. It enables humans to be able to see patterns and observe trends from some type of visualization dashboard, where data is vividly portrayed through lines and stack or pie charts and so forth and so on in 2D or even in 3D models. And in fact, at one point I was kind of trying to figure out, have we actually moved into IoT, or I should say industrial IoT 5.0, where that's bringing the whole visualization aspect to, say, a smart factory, where you gamify an application. So think Call of Duty and using your Xbox controller to walk through a manufacturing facility, and walking up to a twin or digital twin of a device, again in full 3D, right? And interacting and turning switches on and off, and turning pumps on, air conditioning units, and just all those different ways that we can interact now with those devices that are on the edge. Except we're doing that using an Xbox controller. So visualization, not only being able to visualize your data, but just visualizing the whole interface of what IoT can bring to the equation. And if you kind of step it to the side, you can kind of ask yourself, if you have that type of capability, now we're taking these millennials and all these various different names we have now for X, Y, Z generation, right? And we're handing them an Xbox controller instead of giving them a computer, a keyboard and mouse. I was actually at an event recently, and it was a father-son were there. It was interesting. Came to our networking event, and I just, right in front of the guy, I asked his son, what would you rather have, keyboard and mouse or an Xbox controller when it comes to interacting with a computer? You've got to type and so forth, and there was just no doubt I'd rather use my Xbox controller. So we've got to start thinking a little bit more outside of the box on how we interact with all this data. So visualization isn't just pie charts anymore. It's gamification. So I talked about the external interfaces. We're connecting all this stuff to the edge, but we've got to integrate that with third-party systems and the rest of the wider IT ecosystem by building an application programming interface, or API, or a software development kit, or SDK, and gateways. So that's how we're going to interact with all these devices that are on the edge, is through APIs, SDKs, and, as I said, through the gateway. So yes, I did say 8. You might be counting up here on the slide and see that there's not 8. Well, the additional is additional tools. We need to allow IoT developers to prototype, test, and market an IoT use case, creating platform ecosystem apps for visualizing, managing, and controlling connected devices. What we believe separates the run-of-the-mill IoT platform from the exceptional is the exceptional will have implemented the following components, such as digital twins that I mentioned earlier, multi-tenancy. In other words, it's a platform that you can run various different smart apps out of it. The capability of over-the-air updates and access control. So you can see here on the slide the various different other components that that you'll see kind of lack in the traditional. We ingest a device, we give you data, and we can do some charts and graphs, but we're not interacting with the rest of the world. It's kind of myopic. So we've been talking about sensors. Looking at sensors, there really are 3 different categories. We've got physical monitoring with sensors, motion sensors and security sensors, environmental monitoring. So we always think about, when we say sensors, temperature and humidity, and maybe gas and VOC sensors. But there's all kinds of different sensors for being able to determine torque and liquid going through a pipe, Of course, we consider cameras now as camera sensors. So it's a way of providing data into a platform and then using AI, as we said earlier, to do facial recognition, various different things that we can do with that. In fact, we just recently delivered a project about 9 months ago, where we had built a kiosk and had a temperature sensor and a camera, and we're able to blend the data. And as you walked up to that kiosk, it actually was taking your temperature, and it was determining whether you might be contagious. So not only did it have a nice little hand sanitizer dispenser underneath it, but it would tell you go to the right or go to the left. You either were allowed to go to work or asked to talk to somebody about your hot body temperature. So again, just being able to utilize all these different sensors that are available within the ecosystem. So let's take a quick look at connectivity. All right, so all these sensors have to communicate some way back into your IoT platform. So this is where, let's just say, someone who's been there, done that, can provide a lot of insight. And specifically, if you look at the chart here, you can see that, going up the side here is throughput. As we were talking earlier about monitoring cows, right? We might want to take body temperature. We might want to do location. There's a various different data points that we might be able, that we want to extrapolate from our inventory, right? So how often do we need to get that data? Maybe once a minute, maybe once an hour, maybe once a day, maybe once a week. So you don't want to necessarily pay for this high throughput, which would be equivalent to, say, running a 4K movie, or running that type of resolution that might be required for security, versus just taking a couple of data packets and sticking that in the database and starting to look for anomalies or issues. So throughput becomes a variable. And then, of course, coverage. Let's just talk about the cows again, right? Do we need to be able to look out over that farmland that's 10 meters, 100 meters, a kilometer, 10 kilometers? If we're talking about a large farmer, we probably want to have a large capability as far as coverage. So looking at this chart here, various different technologies, you can kind of get an idea that there's no one technology that does it all. There's some that kind of do a good job of it. And specifically, I'll just say LTE is a good example of that. Cell phone coverage, being able to locate an object or a device or high value asset. There are technologies today that allow you to use, say, GPS. That's good outside. Bring that device inside, and good luck. You're not going to get the pinpoint accuracy. Then you've got Wi-Fi, right? I could use Wi-Fi to triangulate, find out exactly where an asset is within a building. But then I go outside, and all of a sudden now I've got to set up access points and harsh conditions and weather issues, a whole bit. IP67, blah blah blah. There's all kinds of standards for that. So LTE actually does really well outside just as well as it does inside. So again, there's all kinds of different variables that you need to take in consideration. And as Volkmar mentioned earlier, battery is the one that I typically think of at the very first. So the battery is pretty much what limits. So people ask, let's put this thing out in the middle of a field somewhere, and I want to stream data back. Well, then I ask the question, how often do you charge your cell phone? Every night. Okay, so how are you going to charge that battery that's sitting on a pole in the middle of nowhere, maybe in an oil field or whatever? So those are issues that you need to take in consideration beyond just what we were talking about earlier. So let's talk about security. Security we got to have it. I mean, there's no way around it. I mean, we've heard all the crazy stories about casinos being hacked by somebody walking in and getting in through a fish tank, IoT monitoring temperature, which is connected to the internet or the intranet within that organization, and bingo, you're in. So you've got to have a certain level of security that you are addressing within the whole IoT ecosystem. Excuse me. But how much security is required? I mean, to what extent? Are you setting up VPN tunnels for everything? It gets to the point where there's a whole management nightmare now that's created around security. So all that said, we've got a balance. Some of the things that we're hearing about is factory floors that have been automated to some extent. And unfortunately, we're finding admin as the username and password. But when they're talking to the IT department and they're asking for these crazy long security passcodes and all various different levels of authentication, if the IT is not there, IT guy is not there on site, and the factory floor effectively gets shut down because the device needs to be rebooted, you're talking about thousands, hundreds of thousands of dollars just because you got this crazy security level. So there's kind of a fine line there. But at the same time, this one might shock you. Just recently at one of our IoT breakfasts, again, I encourage you to go to www.meetup.com/IoT Texas and sign up. We actually had someone who was an IT security expert, and they were able to go in and interrogate everything they saw within the ecosystem. And the one thing that they found was very surprising is that consistently in the data center, the KVM, the keyboard, mouse, and monitor interface that connects to all these different computers, consolidated under one keyboard, mouse, and monitor, still had admin as the username and password. And it was running software that was 15 and 20 years old. So talk about your weakest point within a data center. It's the KVM. So you just don't know where those issues are unless you have, I'll call it a security suite. So you just need to keep in mind that you've got business critical information that you've got to secure. You just don't want to be a CNN moment. That's the bottom line. So you need to support that security model to some extent, and keep within the guidelines that the IT department is providing. And as I said, it's a negotiation. So Volkmar, why don't you go ahead and talk about some of the compliance issues, because Volkmar's is a world traveler. and that said, can you kind of talk about some of the various compliance issues that are not just important in the US, but are global issues now? And as we start becoming more globalized, we really have to go into some of these compliance issues. Volkmar?
Yeah, thanks, Gary. Obviously, we're now focusing more on the American compliance requirements, and there are different organizations which require, depending on what vertical you're currently working on, different forms of compliance. And this is very important. What is not on the slide now is, for example, the FCC. We were talking about certain protocols before and connectivities, and some are regulated. And if you're going in there with a device that is not approved by the FCC, you're getting into problems, because you're acting on a regulated territory. And if you're not paying to be on that you can have stiff fines. That's going up to $10,000 per day. So you have to be very sure. And I'm not so much familiar with the Sarbanes-Oxley and the other HIPAA requirements here, but they regulate certain industries, and certain industries are obviously very regulated, such as medical industry, which is regulated by the FDA, the food industry, also FDA, so you have to make sure in everything you do, you're compliant with those regulations. You need to get an expert or expert company who consults you. If you don't have that in-house, if your organization is too small, that with your whole IoT chain, you're compliant with the different laws and regulations inside your state and inside your country, because otherwise you can get into real trouble. And there are different forms of audits for that, and compliance reports and so on. And depending on what regulations and what business you're in, you have to be compliant with those, and you have to show proof of you fulfilling those compliance issues. So now I'm going into the economics framework. We will talk into different about different time frames. I mean, philosophies, what you want to achieve. You know, you want to improve efficiency, which is relatively fast. You want to drive revenue through innovation. That's midterm. You have to develop products from your knowledge, or you want to transform your business completely with the data you get. That's obviously long term, and obviously most of the companies have to keep all three things in focus. Typically, for one IoT capability is remote monitoring, which improves efficiency because it gets insights into the assets at the location, and removes or makes sure the field service personnel only comes when it's really needed. Yeah, because you don't want to have people. So that changes the whole game from people coming like on certain time scales, let's say every 6 months to inspect, to when it's really needed. For example, there are IoT startups out of Germany that that are inspecting railroads, and they have sensors in the switches to make sure everything is, and on the brakes of the trains and on the wheels to make sure they are technically up to date. But this not only does it increase safety, but also efficiency, because then we know exactly when you need to exchange certain parts when they have reached a certain quality that's not safe anymore. Yeah. And then we're talking about that's also a form of asset management in a way. Now you could go to the example of a vending machine that's managed through IoT, that manages how many assets, basically what you sell in there, are available, and make sure the machine is filled up according to that, so you don't lose revenue, so people don't come to the vending machine and find it empty. Yeah, So, and then in the business transformation, you basically leverage all the data and have predictive availabilities to predict, for example, when you're supplying a automotive company, that you make sure you have enough things in stock, but not too much. So you make sure you don't bind too much capital. And basically this form of automation and IoT supports that you're staying you're staying in compliance and in support of the company you're supporting. Depending on your industry, you might have all three: remote monitoring, asset management, and predictive analytics, or only one of those that you need to monitor and manage. So the typical financial benefits of improved efficiency through IoT are basically lower maintenance costs, increased uptime, and lower consumption of input, fuel, and more efficient machinery processes. So there are examples to everything. I'm just putting out lower consumption of input, for example, and that's where I write my PhD thesis on, and covering my last startup. We had this hybrid energy systems consisting of solar panels, diesel fuel motors, and batteries interacting with each other, and you have basically sensors on all of the three components, which then through optimization lowers the consumption of diesel fuel on site. Yeah, so you improve efficiency. Now you do that for hundreds of thousands of towers, you save billions and billions of dollars in cost. Yeah, because the costs are so much fueling those things up, and the improvements through IoT are between 25% and 50% if it's not optimized before. So that brings your payback time sometimes as low as 6 months on the equipment, because the equipment itself, the sensors and the connectivity is basically not very expensive. Yeah. So revenue growth, basically you create higher customer satisfaction when you exactly know what they want, and you faster know what product lines, new product lines you need. And from this data, of course, not only from IoT data, there's much more data associated with it. But basically, coming back to this vending machine again, you have the exact numbers when someone consumes it, how fast it's consumed, and how fast you replace it. So you can take out product lines that don't sell, basically, or you can put on certain product lines that sell in a specific time, during a specific time, and take others out when they don't sell, so for example, seasonal products and so on. Yeah, so all over you have much more data, and that data can fuel your strategies and can make you react much more faster on your environmental challenges than you could do without the data. Yeah, so this is all improving your business, your bottom line, and increasing your revenue, decreasing your cost. However, it has to be set up properly from the beginning, as we previously alluded to. Now I give it back to Gary on that vending machine example.
Yeah, I'm just going to go ahead and expand just a little bit on what Volkmar was talking about here when it comes to vending machine, kind of using that as an IoT example. Effectively, an IoT-enabled smart vending machine can reduce the cost, increase revenue, and improve customer service with a single centralized point of control. The vending machine operator is able to ensure machines are kept stocked, optimize logistics and maintenance schedules, make sure that you're getting route optimization and from machine to machine, you're not filling it up with things that, as Volkmar talked about, that they're non-sellers, and the ones that are selling, you've got those analytics. So effectively, you're moving products from machine to machine, and then using the analytics, some area might sell, say, cold drinks versus hot drinks. It might be, depending on whether it's inside or outside and so forth. So that all those analytics can be brought up through an IoT platform. So just having that type of information, you can think outside the box here, create marketing and promotional campaigns there on the machine. So understanding your business better through data analytics, and to achieve an ROI, you must understand what you need for successful IoT deployment. Volkmar?
Yeah, so I alluded to it before, but now we have a couple of examples in different industries and use cases and financial benchmarks specific to the industry. This is the overview slide, and I break it down and according to industries. I chose a couple of this slide, but I'm being able to show you more when you request the slide deck. You can have more time to look over this. So here we have the example of a medical monitoring device and monitoring of a medical machinery, which can fix 30% of problems remotely, and so far lowering the maintenance cost, because you do not have to send someone there, a technician, that costs you money. And in addition, the reduced downtime is by 40%. So basically you increase the uptime of the machine. Obviously, then you can send more patients through your throughput in a way, and so you make more money and you reduce costs. In result, you're more competitive in comparison to your competitors. In energy here, use case predictive maintenance of alternative fuel generators, reduces maintenance costs by 50% and reduces downtime and saves the customer 1.2 million and reduces chemical consumption by 70K and cooling tower performance improvement by 450K. So anyway, so basically you have two cases or two in one: predictive maintenance reduces downtime and reduces on-site repairs. So you have a large cost savings here. Cost savings gives you more cash flow for yourself to put money into other operations like marketing and sales, and makes you more competitive. And then using alternative fuel lowers input and consumption and gives more efficient throughput. Again, reduction in cost significantly, more cash flow for other things. So in the end, and here in manufacturing case, real-time error corrections in the plant minimize rework, saving 550K. We currently, Gary and I, work on a quality management process program where we optimize the workflow, use IoT sensoric cameras and touchscreens for that. I can't reveal too much about it. It's in the automotive manufacturing in Texas. You optimize that workflow, you save money, you minimize rework, you save money. I mean, this is not our example here, but that's the remote manufacturing of automation system increased productivity by 30%, boosted revenue by 70. So again, so putting all this together, you probably, depending on the industry you are, you will need IoT at some point, because it's there's no doubt that you will improve your competitiveness from IoT. However, you need to deploy it in the right way. But if you don't do it, your competitors will do it eventually, sooner or later. And then you're in a competitive disadvantage if you don't have the data, if you don't have the processes that give you then as a business leader the insights to strategically position your business better, to have more cash flow on hand, to do other things with your business, to grow your business. So you have to have it. So again, here on this slide, we are putting together the long-term value of what's happening. Basically, you boost performance. You decrease service and product costs. You can create new revenue streams. You can improve customer relations, optimize your offerings, and create new business models or substitute offerings. As I said, you know, from the vending machines, yeah, if you find out that XYZ, whatever your mass doesn't sell, but this other product sells much better, you obviously substitute the offerings to those who are in more demand. This could also be in a supermarket where you enable IoT. You can drive out new business models when you find out your current are not working. And you improve your customer relationships if you are more, if you're better supporting their needs. Be it your automotive company, who you better support with just-in-time production. I mean, it's already happening. Or be it your customers in a retail setting. So no.
Okay, so we've been looking at several different industries where IoT adoption is significant. We'd like to conclude with a little deeper look at a specific use case around preventative maintenance. So again, our use case here of field service, right? Preventative maintenance. So we don't want to go out to ATM and do any additional work on it that's absolutely necessary. Keep it just to where the brakes truck's coming around and putting in the two bricks that they do of $20,000 each, $40,000 sitting in these machines at any one given time. So we want to make sure that it's doing its thing. So effectively, IoT can reduce the maintenance cost and time required while increasing customer satisfaction. Machines need regular upkeep and maintenance, but you can schedule that according to what data you're getting from your specific location. So instead of, I'll just step aside here, Starbucks actually was looking at using IoT to determine when should they go out and clean their coffee machine. It was on a regular schedule. They go from location A to B to C to D and so forth. But they realized that if they actually went to clean it and do maintenance when it needed it versus on a schedule, they could save millions of dollars. So they started looking at IoT enabling their coffee machines to be able to do exactly that. So let's going back to the ATM. In this case, after sales service, including servicing parts and labor costs and adding to additional overhead for the company. Maintenance cost is expensive, right? We can always utilize machine data and AI to predict failure, and then perform that preventative maintenance before breakdown and not after. So next slide here. So what is the solution, right? The machine learning model uses mathematical and forecasting techniques to help analyze historical data and predict future outcome. So, again, we're collected over 30 months of company service related data. We're able to put that historical information into an SQL database. And then we were able to segregate that information and actually use mathematical models for forecasting techniques and problematic models and make those determinations and what kind of patterns are showing up and finding the correlations and trends and so forth. So again, predict service time, predict machine failure, know inventory, and just overall increase the efficiency of your workforce in doing that preventative maintenance schedule. Next slide. So we've kind of gone over these a little bit, but just to reemphasize the benefits of increased customer satisfaction, reducing the maintenance cost and time required, better PMP, call service management helps to shut down and slow down those emergency calls. Service time prediction, we're able to predict the time that it will take a technician to complete a call. Smart allocation of the technician and their service talents and so forth, and obviously inventory acquisitions and predicting what parts that might fail or wear out and cut down on the number of visits that you make to that machine on the PMs and again fix those parts before they fail. That failure prediction. And predicting the time of the next machine failure, resulting in, again, fewer emergency calls. So, another use case, just quickly, is just demand forecasting and inventory management. Increasing your operational productivity and forecast accurately through machine learning models. Get insight into your customer, your industry, your macroeconomics trends to optimize your production and merchandise planning process. Optimize inventory across locations in real time using advanced analytics, getting a better understanding of inventory demand patterns, supply network and customer service requirements, obtain a live view to asset inventory levels, predict product fulfillment needs, and identify potential backlog issues before they happen. Use advanced analytics to perform financial forecasts that help your organization collaborate on strategic plans and corporate budgets. Perform sophisticated financial analysis and adapt to quickly using frequent driver-based forecasts and 360 view of your business. Next slide. Spend and resource management. Optimizing your supply side performance, integrating data from across the value chain to analyze it in real time using machine learning models. And by using intelligent insights to making actionable decisions, you can identify opportunities for consolidation and reduce your costs. So next slide. So, the use case here in monitoring rotary unions. What is a rotary union, you might ask? It's a mechanical device that allows transfer of pressured fluid from a stationary source into a rotating mechanical machinery for heating, cooling, or transferring of fluid power. So in this case, the solution is a smart board to collect and transmit the data. It'll fetch the data from the rotary unions and send it back to your IoT platform. And then because you've got that capability, you're going to be able to determine if you've got leaks. Do you have battery drainage that's unnecessary? Do you have is the fluid amounts that are going through that particular device averaging like all the other devices like it? And then you can look at the overall rotations and make sure that you're getting the life out of that particular product. Again, we talked about bearings going bad. You can detect that by having the vibration sensors on there, and all of a sudden you start seeing that vibrating out of spec. So you can start again making those predictive analytics. So next slide, just product development, accelerating your R&D efforts. Usage-based arguments. Analyze real-time product usage and condition data across products and customers with product lifecycle management, PLM, application lifecycle management, ALM, and quality systems to enable data-driven closed-loop lifecycle management using IoT and AI. Immersive product review, integrated CAM and PLM and product data into an augmented or virtual reality experience to enable enhanced design reviews for real-time cross-discipline collaboration, shortening design cycle and reducing physical prototyping. Connected product quality analysis. Analyze new world product usage and condition data with FMEA models and predict analytics from automated root cause analysis, reducing warranty claims and higher quality management and design. And product configuration management is the capability of being able to remotely identify and manage the as-maintained configuration of fielded products and securely distribute software updates to optimize performance, ensure compliance, and remotely deliver new product variants. And then work order management. The data collected by sensors, manual entry through mobile apps, and RFID tags can be used to create an IoT-enabled distribution system backed by data science and visualization. Management can now see the supply and demand of products based on how much inventory is available in inventory. And then this data can be viewed using 3D, 2D visualization in a variety of devices using business intelligence tools, software. Your company can predict the demand. Your company can plan production, and your organization can be able to supply the information that the executive team is wanting to see as far as how to run the business. And then finally, looking at cloud-based infrastructure and building scalable cloud-based IoT systems. The data generated by sensors can quickly run into terabytes or petabytes, as we discussed earlier. To handle this amount of data, a cloud-based approach is cost-effective and easy. The IoT platform can be developed on a cloud platform such as AWS or Azure. And an IoT platform can scale to handle large amounts of data using AI and BI tools. Your IoT data can provide actionable analytics and visualizations. So all that said, I think that brings us to our Q&A. So we'd like to go ahead and if you could, if you have any questions, please feel free.
Thanks, Gary.
Go ahead, Volkmar.
Sorry. So I'm gonna stop the share here, and then we're gonna have you either write your questions. I would like to cover one question at a time, of course. I mean, this will not be like an open discussion round now, but either you write your questions on the chat or you shortly ask the questions, and then we will try to answer them here, or later through text and email if we are not able to answer them straight from this event here. Thank you.
So are there any questions at all?
Did you, Gary, did you see any questions in the chat?
I did not.
Okay. So, are there any questions? Or is it already